This is another Mathfolio math tutorial. Today's topic is on radicals, the notation for radicals, and also how to simplify basic radicals themselves. Please download the Mathfolio math sheet for this lesson, which will be useful as you go through and watch the different sections. You'll be able to complete the math sheet and also do the extra questions at the end for homework, extra credit, and just to self-check whether you understand the topic that we've been discussing. The worksheet for the lessons is available at mathfolio.com/mathsheet. Hopefully you've seen some of the other videos that I've made on exponents and radicals, especially the law of exponents and also fractional exponents. Those are really important and can help us understand the use of radicals. But let's just jump in. If you've seen something like this before, you might know this is the square root of 4, and you might even be able to say, well, this is 2. So let's take a little bit of a closer look at this. When we're dealing with the square roots of something like 4, what we're really thinking is what times itself gives us the 4. So when we're thinking about what times itself gives us 4, we're thinking, well, it could be 2 times 2. Now keep in mind also, it could have been -2 times -2. Now really, when we just do this square root sign, there is also a little 2 that's with the radical sign. So really this square root sign here is also known by the word radical. So we can say that this is radical 4. Now radicals don't always have to be square roots, they could be cubed roots. So let's take a look at one of those examples. If I say the cube root, now here we can't leave it as this because this is going to imply that it's the square root a little 2. If we're talking about the cube root, I've got to put a little 3 there. So let's take the example of 1000. Now if I'm looking to try and find the cube root of 1000, we're thinking about what times itself 3 times now, because this is the cube root. What times what times what gives us the 1000 back? And so in this case, it's a nice number, 1000, so we can think that this is 10 times 10 times 10. And so in this case, cube root of 1000 is going to be 10. And over here, I didn't write the answer, I spoke about it, but the square root of 4 is 2. Or -2 in this case as well. But in the cube root example, we can't say that this is -10 times -10 times -10, because negative times negative times a negative is going to end up negative, because these two right here would give us a positive 100, and then if we went on to multiply by -10, we'd end up with -1000, which we don't have underneath there. So this really is the building blocks of radicals. We've got square roots, we've got cube roots, we could have to the 4th root, and then we would be looking for which number times itself 4 times. That would give us the number underneath the radical sign. So let's just build on this a little more. Now I mentioned that in the case over here, in the square root of 4, that the answer could have been a +2 or even a -2, which is all fine. Now usually when we've got an index, now the number next to the radical sign right here, the 2 and also the 3, those are each called an index. So when we've got an index that's an even number, usually our answer is going to be positive. And that's the answer that we're going to be referring to. So even though the square root of 4 could be -2, most of the time we're only dealing with the positive value of that. However, in this next example, let's just take the cube root of -1000. So look how this is different to our example up on the top right, where we're after the cube root of 1000. This time we need something times itself 3 times to give us an answer of -1000. So in this case, our answer would in fact be a negative number, because it can't be 10 times 10 times 10, because those are three positive numbers multiplying, and so that would give us a positive 1000 answer. However, if we've got a negative times a negative times a negative, that is going to give us a negative, and then if we fill in the actual number that gets us to 1000, it's going to be 10 times 10 times 10. So the cube root of negative 1000 has to be negative 10. It can't be a positive number in this case. Okay, and just one other very quick example that I'd like to look at is the square root. Now we could just leave it like this, but I'm just going to show the little 2 there. That's usually invisible if there's no other number, if there's no other index that's with it. Let's just say we're looking at the square root of negative 4. So square root, we're looking at a number times itself 2 times. The index implies the number of times the number is going to multiply by itself. So we're thinking, what times what gives you negative 4? And they have to be the same number. So it can't be negative 1 and 4. It can't be negative 2 and 2, because it has to be exactly the same. And in this case, if they're both positive numbers, it's going to give us a positive answer. So it can't be a positive value. But also, if they're both negative, and negative times a negative is going to give us a positive. So there's absolutely no way that we can get back to negative 4 from the same number times the same number. And so in this case, we would just say that there's no real number solution. No real number solution. Now, some of you out there might be thinking, well, there's imaginary numbers. And imaginary numbers are outside of the real number system. And it's basically where we use the letter I to represent the square root of negative 1. However, that's not something we're going to look at in this tutorial. So if you're looking at the square root of a negative number, for the purposes today, just think of this as being no real number solution. Now, the one other thing that I want to look at before we move on is an example of simplifying radicals. So let's just take a look at this. If we have something that is the square root of 20, now 20 is a non-perfect square, but we could estimate it. It's between the square root of 16, which is 4, and the square root of 25, which is 5. So it's somewhere between 4 and 5. However, in simplifying radicals, what we would do is we would look at the factors of 20. So 20 is 4 times 5. So we could keep splitting the 4 into 2 times 2, but what this also means is that we could write this as the square root of 4 times the square root of 5. Now the reason why this is kind of nice is because the square root of 4, well, 4 is a perfect square, so we could rewrite this as 2 radical 5. Now 5 can't be broken down anymore, and we can't get any perfect square as a factor of 5. So this would be the simplified version of the square root of 20. We would just pull out any perfect squares by square rooting them and putting them in front of the radical. Notice this 2 isn't an index, it's a big 2 that's right next to the radical 5. So that's a multiplication that's going on between these two. Okay, let's take a look at one other very quick example of pretty much the same thing. This time let's look at the square root of 300. And if we're asked to simplify this, we could say, well, this is a square root of 3 times 100. And we could keep splitting 100, but 100's a perfect square, so we should probably stop. This is the same as radical 3 times radical 100, and the square root of 100 is 10, so again we can bring out the 10 and just put it in front of the radical 3, and so this would be our simplified version of radical 300. So far we've looked at the basics of radicals. We've also looked at the basics of simplifying some radicals. And one thing that I want to do just before I move on to the vocabulary is to look at exponents and how they tie in with radicals. So if we have radical 4, which we've used before as an example, then as we know, this implies that there's a 2 there. If there's no other number, we assume it's the square root, so it's with an index of 2. Now we could also write this as 4 to the 1/2. So let's take a little bit of a closer look at this. So if I have something that is a to the b over c, what this really does is we can separate this and think of this as a to the 1 over c, all to the power, not multiply, all to the power of b. Because if we remember our power law of exponents, to go back from this, we would multiply the b by the 1 over c, and we would have the a to the b over c. Now, we need to think of this as we're able to pull out the b and have that as the overarching exponent. And when we have a fractional exponent like a to the 1 over c, then this inside is really radical a with the index of c. And then obviously on top we have this in parentheses, and we're doing this to the b power. So let's try this with a few very quick ones right here. If I've got x to the 1 over y, then we could write this as radical x with an index of y. So if this was x to the 1/3, then this would be the same as the cube root of x. So radical x with an index of 3. Now, if this was x to the 2/3, then again we could go from this to knowing that this is x to the 1/3 all to the second power. And x to the 1/3 is the cube root of x, and then we could square the whole thing. So these are just some really a very quick introduction to fractional exponents and how they tie in with the radicals, really. So when we're thinking about a square root of something, really what we are doing is we are doing that something to the 1/2 power. These two are exactly the same. So just brief recap at some of the vocabulary words that we've been looking at today. We've got radical, which is this symbol, and anything that's underneath it would be radical followed by that number. The index relates to the number that is next to the radical. Here we're talking about the cube root. Base refers to a number or a variable that is underneath an exponent. So here the base would be x. The exponent or the power is the number that's to the upper right of the base. Repeated multiplication refers to exactly what exponents are doing. So 2 to the 3rd power is actually 2 times 2 times 2. So it's repeating the multiplication of 2 by itself 3 times. Exponential form is when we leave an answer with exponents. So if I said what's 2 times 2 times 2, you could say, well, it's 2 to the 3rd power. Radical form is just as we simplified some of the other things. We simplified radical 300, square root of 300, by writing 3 radical 10. This is an answer in radical form. And simplifying is really when we make something that's kind of complicated or has a lot of detail, and we try and put it in its simplest or its easiest form, or even in a form that we're able to use more readily. Okay, so here we've got 3 examples. So let's go through these and take a look and see what's going on. So in the first example, we are asked to evaluate the square root of 100. So square root of 100, we're thinking about what times itself gives us 100. So hopefully we're used to our multiplication tables, and we can remember that 10 times 10 gives us 100. So the answer here is 10. Now, you could also say that negative 10 times negative 10 also gives you 100, and you would also be correct in saying that the answer to the square root of 100 is plus or minus 10. However, just keep in mind that usually we're really only focused on the positive value for the square root of a number. And in certain cases, when that positive value doesn't satisfy the radical expression, then it would be a negative answer if that also works out. Okay, for number 2, we're looking at the cube root of negative 1000. This looks like one that we did earlier. So we're looking at which number times itself 3 times gives you the negative 1000. So here we've got to be a little careful. So our answer is going to be negative 10 times negative 10 times negative 10. It can't be 10 because 10 on its own, a positive 10, because if it was positive 10, 10 times 10 times 10 would give us 1000, and we need it to be negative 1000. So here in this case it's not plus or minus, it's only negative 10. Okay, number 3, this is also similar to the other one that we did earlier. Write the square root of 20 in its simplest radical form. So this would be the square root of 4 times 5. 4 is a perfect square, so we can pull that out, and the square root of 4 becomes 2. Radical 5 stays, so this is our answer, 2 radical 5. For the Q&A, you should really attempt these yourself. Press pause on the video, and then after you've attempted them, come back and press play and check your answers. Okay, so I'm about to solve them now. For number 1, we're asked for the square root of t squared. So what this square root does is it actually cancels out with the square. It's the inverse operation of squaring something. And keep in mind the index for this radical is 2, even though we can't see it. Without a number, we assume it's a 2. And so the answer for this one is just t. Now, we can also take a little bit of a closer look at this. If we've got t squared all square rooted, remember, if this is square root with an index of 2, that's the same as saying this to the 1/2. The square root is the same as the same term, but with the exponent of 1/2. And so if we remember our rules, our laws for exponents, right here, the power law states that we've got to multiply a power to a power. We would keep the same base and we would multiply them. So 2 times 1/2 is 2 halves, or 1, which t to the first is the same as t. So that's an explanation of exactly how we come up with t. But if you remember that when we square root something that's being squared, we get back, then that's also great. Okay, for number 2, in this question we're asked to find the cube root, and so we're looking at something times something times something that gives us an answer of negative 125. And so in this case, if we can remember you know, certain things like 2 cubed is 8, and 4 cubed is 64, and 5 cubed is 5 times 5 times 5. Well, 5 times 5 is 25, times 5 is 125. So we know 5 has something to do with it here, because 5 times 5 times 5 gives you the 125. But we can't forget this negative. So in fact, if we think about this, negative 5 times negative 5 is positive 25, and then when we times positive 25 by negative 5, we do get to negative 125. So our answer here is in fact negative 5. Now if we ever get lost with this, what we can do is we can zoom in and focus on what's underneath the radical, and we can think, well, 125, negative 125 is really negative 1 times by, and then we can say it is 5 times 5 times 5. So the 5 times 5 times 5 gives us a 125, and when we times that by a -1, we get -125. So because this is cube root, we can see here that the 3 is multiplying by itself, sorry, the 5 is multiplying by itself 3 times, and so we know 5 is a part of this. And so then we just need to think through the situation with the negatives. Okay, number 3. Here we're asked for the square root, but this time it's a term containing a coefficient and a variable with an exponent. So because this is a square root, there's no number, but it's implied that the index is 2 without a number. And so we could think of this as the square root of 80 times by the square root of p squared. And remember, the square root means, really, it means p squared to the 1/2, which when we multiplies out becomes p to the 1, which is just p. But we still have this square root of 80, and the p we could actually bring in front of the radical right now, but for now we'll just leave it like this. If we keep investigating this, well, we can say that square root of 80 is the square root of 4, and if we divide 80 by 4, we get 20. So 20 is also 4 times 5. So we could bring out the p, so the p is not underneath the radical right now. But this is also the same as saying the square root of 4 times by the square root of 4 times by the square root of 5. So you'll notice that I'm bringing each of these out. Now 5 isn't a perfect square, but 4 is a perfect square, and so is that other 4. So this is the square root of 4 is 2, so it's the same as 2 times radical 5 times p. Now the radical 5 we're going to leave at the end, but now 2 times 2 is 4, and 4 times p is 4p. So the simplified version of square root of 80p squared is 4p radical 5. And so it looks more complicated, but this is the most simplified version of 80p squared. So we're trying, our mission is to try and bring out as much of the stuff as we can that is underneath the radical sign, and that's exactly what we did in our answer of 4p radical 5. Okay, so this is your turn. Please do these questions for your own self-assessment, whether it's for homework or extra credit, but just to prove to yourself and your teacher that you understand it. Please pause the video and copy these down into the 6 boxes on the reverse of the math sheet. And this is the monster question. This really should show how much of this math tutorial you understand. Here we're dealing with simplifying, we're dealing with cube roots, we're dealing with a negative, and so your mission is to try and break this up into a simplified radical expression. That's the end of the math tutorial. Thanks for watching. I hope it was useful, and please don't forget to subscribe to the YouTube channel and also to leave a comment. Many thanks.